In this video, we'll introduce the idea of an improper integral. Let's first look at the graph of 1 divided by x squared. And for the moment, we'll just focus on the right side of that graph. In the past, when looking at integrals, we started with an a value, let's say 1, and we evaluated up to a b value. And we ended up with a finite area under the curve. But what if we wanted to extend this b value to infinity? Would the area under the curve then be infinite, or would it become a finite number? Would the area under the curve, if we extended it forever, would it get small enough, fast enough to converge to a finite value? That's what we'll be investigating in this particular example. Another type of improper integral will be the case where we have a discontinuity. Let's say we were looking at the area from -1 to +1 and we have a discontinuity in the graph. We'll look at that in a future video. In this case, what we'll do is we'll say that this value is t, the upper limit of our integral. But then we want t to get really, really big. We're going to push t to infinity. That brings us back to the concept of a limit. We'll have the limit as t approaches infinity of the integral from 1 to, we'll change infinity to t of the function 1 divided by x squared dx. These kinds of problems can sometimes get a little tricky because we have to first integrate, and then there's multiple different rules for integration. We have integration by parts, partial fractions, trig substitution, multiple different techniques there. Then after you integrate, you have to then go back and practice those limit rules. So sometimes these problems can get a little tricky. This one isn't too bad. I'm going to first rewrite the functions. We have t going to infinity of the integral from 1 to t of x to the -2 dx. Then actually evaluating that integral, we'll just bring down the limit. The antiderivative of x to the -2 is -1 divided by x. And we want to evaluate that from 1 to t. Again, we'll just copy the limit for now. Plugging in those limits of integration, we have -1 divided by t minus -1 divided by 1. We now have the limit as t approaches infinity of -1 divided by t plus 1. We've now taken care of the integral. We can look at the limit. Notice that t is getting really big. If this denominator is getting really big, it's going to infinity. The fraction is approaching 0. So we have 0 plus 1, which is 1. Notice we got a finite number. That means that the integral is convergent. That original integral that we had up here, we can now say that this is convergent because it converges to a finite number. If on the other hand, the limit had ended up being infinity or negative infinity, we would say the integral is divergent. We'll see some of those examples in future videos. So to recap the steps for improper integrals, first we replace the infinity with t. And then we make the limit as t goes to infinity of the integral. Calculate the integral just like we would with definite integrals in the past, and then finally evaluate the limit. And then at the end, if you get a finite number, we can say the integral is convergent. If you get infinity or negative infinity, we would say the original integral is divergent.